Okay, here we go, folks. So this is topic 8, student activity sheet 4, exploring linear inequalities in one variable. Okay, I want you to go ahead and cross off those first two problems. We're going to skip through that. And I want you to head to the back side. And we're going to start with question 7, which is really like the third problem. Okay, so they want us to just simply solve this inequality. And this is the inequality that we saw back with the whole dune buggy problem. Okay, so with this, guys, you may notice the only thing different here is this little fancy schmancy symbol. Okay, we don't need to worry about that for right now. I want you to solve this just as if it were an equal sign. Okay, so here's my problem. We're going to draw that line right through the inequality symbol, just like we would if it was an equal sign. We need to get this m by itself. So first thing we do, get rid of the addition subtraction. It's a positive 29.95. So we're going to subtract it on both sides. Okay, these are like terms, so we can go ahead and do that. And when I do that, I'm left with 0.16m is less than or equal to $45.05. We need to separate that 16 from the m, so we're going to divide by 0.16 on both sides of that. And I'm left with one single m is less than or equal to 281.5625. Okay, so now on question 8, what they want us to do is represent this using a number line. Guys, that's a fancy way of saying graph it on a number line. So a couple things before we get started here. As a reminder, in case you didn't remember, with inequality symbols, we have a couple different kinds. We have our less than or greater than symbol, in which when we use a number line, we use an open circle because it cannot equal the number. Okay, if I say I have to spend less than $50, that means I can spend $49.99, but I'm not going to spend the full 50. So again, we're going to use an open circle to show that it does not include that number. It simply is the limit. So then if we have our less than or equal to or our greater than or equal to, whenever it's got the little line underneath, that means that it can include that number. We're going to use a filled in circle. So with this, I'm going to come over to my number line. Now, guys, you don't have to like fill in a whole bunch of numbers. We know the typical, if we have 0 here, I know that my positive numbers are to the right and my negative numbers are to the left. So what I'm going to do is I'm going to put like negative 100 over here, and I'm going to show my 281.5625 over here. Okay, we have the little line underneath the or equal to. So I'm going to use the solid dot. And here it says m has to be less than. So where is my less than? Towards the 0. Okay. Now they want us to do this a little bit different. This time they want us to do 0 is less than or equal to m, which is less than or equal to 281. Okay. So guys, this is more like money right here. We can't spend a negative amount of money. Okay, I guess that's what they call spending money you don't have. But with that, what I'm going to do here is I'm going to do just like I did before. I'm going to put my 0 here. I'm going to put my 281 over here, and I'm going to put negative 281 over here. Okay, now they're telling us two different things. They're saying we can spend $0. So I'm going to put a solid circle there. Sorry, they're saying we can spend $0. They're also saying we can spend $281. So I'm going to put a solid circle there. And they're saying that my numbers have to go in between. I cannot spend more than it. I cannot spend less than that. Question 10. A cell phone company charges a flat rate of $25 a month. Okay, so I'm going to circle that. Plus, that's a math word, plus 15 cents, as a reminder, that's written as 0.15 per minute. Per means to multiply, and M is usually going to be our variable. I'm going to use M for this time. If Marco's bill was over $55, guys, that word over, you want to write it over there, over means greater than. Write an inequality to model the situation, then solve the inequality. So what I did here, guys, is I took what we said, 25 plus 0.15M has to be greater than $55. So I'm going to go through and solve this, subtract 25 on both sides, and I get 15 cents M has to be greater than 30. Divide both sides by 0.15, and I get that M has to be greater than 200, meaning he has to spend, if his bill was over $500, that means that he had to talk for more than 200 minutes on the phone. Whew, that's a lot. I hate talking on the phone. You call me, I probably won't pick up. Let's go on. We're going to cross off question 14. Question 12. This is a good spot that you could write these notes. Just a little bit of a reminder. Okay, just a little reminder. Open circle for greater, open circle for less than. If it is a greater than or equal to with the little line underneath, we're going to use closed circles. If it flat out says equal, we're going to use a solid circle. And if it says does not equal, we use an open. So let's take a look at these. Okay. What I want us to look at is just what the operations here. Okay. So we have these numbers 2 and 8 that we're going to compare. When we add, we get 3 and 9. 3 is less than 9. When we subtract the 1 on both sides, 1 and 7. 1 is less than 7. I went through and I did these for all of them. Okay, 4 and 10, 5, 11, 0, 6, negative 1, 5. You can see it doesn't matter if we're adding or subtracting, the amounts stayed the same. That is if we're using the same numbers on both sides. Okay, what do I notice when we add the same thing to both sides or subtract the same thing? Maybe add that note in. When we add or subtract, they have the same relationship as the original inequality. Remember, the original inequality is comparing 2 to 8, and 2 is less than 8. The directions of the signs never changed when we added or subtracted the same amount. Okay, let's go on to 15. Okay, what did we notice? Again, with the subtraction, same relationship equals the same sign. So now we're going to do the same exact thing using multiplication and division. Okay, so I went through and I marked 2 times 1 is still 2, 8 times 1 is still 8. And we did this on both sides. Okay, when I multiplied all of these by positive numbers on both sides, my sign stayed the same. But over here, when I multiplied by a negative, for example, I did 2 times negative 1, which is negative 2. 8 times negative 1 is negative 8. Be careful here, guys. Negative 2 is actually bigger than negative 8. Same thing over here. And so if I do 2 divided by 1, that's still 2. 8 divided by 1 is still 8. 2 is less than 8. But if I look here, 2 divided by negative 1 gives me the negative 2. 8 divided by negative 1 gives me negative 8. Negative 2 is bigger than negative 8. So what I noticed here, guys, when I am adding or subtracting, like I did on the previous problems, my sign stayed the same. But when I multiply or divide by a negative number, my signs flipped. Okay, here I multiplied and divided by a positive, and my relationship stayed the same. But the second I did it by a negative number, my signs flip. So big thing here, guys, circle it, highlight it, star it, do whatever you have to do as a reminder to yourself that whenever we multiply or divide by a negative, we have to flip our sign. So let's do a problem here. We have 8 minus 2x is greater than or equal to 14. They want us to subtract 8 from both sides. So here, I'm going to get, my letters are already on the left. So we're going to move that 8. So I'm going to minus 8 on both sides. And I'm left with negative 2x is greater than or equal to 6. Now to solve this, I have to divide by a negative. Ding, 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 ding. Okay, you'll see I circled those in red to show you, hey, we divided by a negative, which means I have to change my sign. So what I end up with is x is less than or equal to negative 3. Question 19. Same problem, but this time they want us to work backwards on it. Instead of subtracting the 8, they want us to add the 2. So let's go ahead and add the 2x to both sides here. What happens here, guys, is that this 14 and the 2x, they're not like terms. So we can't combine them. So what we did here is we wrote them next to each other. What they did was that they made that minus 2x a positive so that we didn't have to divide by a negative. Now, my x is still not by itself, so I need to get rid of this 14. I'm going to minus 14 on both sides, and I have negative 6 is greater than or equal to 2x. Divide by 2 because I want to get that x by itself, and I get that x is less than negative 3. But again, I showed you guys before, we don't like to write our symbols this way, okay? I like the x first. So with that, we've got our x, we've got the negative 3. If it helps, my Pac-Man is eating the negative 3, so my Pac-Man needs to eat the negative 3 in my answer. On these, they want us to solve using the distributive property and inverse operations in our algebraic. Guys, that's a fancy way of saying follow our multi-step equation steps, okay? So on these, let's just look at this one first. Over here, distribute the 4, and we get 4x minus 12 is less than 8. Add 12 to both sides, and we get 4x is less than 20. Divide both sides by 4, and we get that x is less than 5. Come over here, start by distributing that negative 3 on the left side, distribute the 2 on the right side, and I get negative 3x is less than negative 24. Sorry, negative 3x minus 24 is less than or equal to 2x plus 6. Get your letters to the left. So I'm going to subtract 2x on both sides. Watch your negatives here. And I get negative 5x minus 24 is greater than or equal to 6. Add 24 to both sides, and I get that negative 5x is greater than or equal to 30. Split that by dividing both sides by negative 5. Okay, negative alert, negative alert, negative alert. Flip your symbol. Okay, and we get that x is less than or equal to negative 6. Okay, I want you to go through these with your teacher, number 21 and number 22. And let's take a look at letter E of that one, okay? What I want you guys to do here, just take this down. I gave you an example here. We've got x is greater than 7, less than 7, x is greater than or equal to, x is less than or equal to, and then I threw some new ones in. X equals 7, x does not equal 7, okay? Just examples here of graphing them, the same number and what it looks like with the different symbols. X is greater, open circle goes bigger. Less than, open circle gets smaller. Greater than or equal to, closed, bigger. Less than or equal to, closed, smaller. When x equals 7, it's just a closed circle. There's no arrows. It's not getting bigger. It's not getting smaller because x equals 7. This one means that x cannot equal 7, meaning it can be any other number except 7. So we're going to show it can be bigger, it can be smaller, but we're going to put an open circle to say it cannot be the number 7. So question 23, they want us to answer the questions. X is less than -1 or X is greater than 4, okay? They want us to complete this table. They're asking, can X be -4? Okay, well, my two rules, X is less than -1 or X is greater than 4. -4 is less than -1, so yes, it's true. -2, -2 is less than -1, so yes, it's true. 0, well, 0 is bigger than -1, but 0 is smaller than 4, so no, that's not true. Pi, guys, that's 3.14. No, pi is bigger than -1, but smaller than 4. The number 7, that falls into this rule here. 7 is greater than 4. 12, 12 falls into that rule. 12 is greater than 4. They want us to list 5 additional numbers that make this statement true. Okay, so I came up with -5 because that's smaller than -1. -100 is smaller than -1. 5 is bigger than 4. 100 is bigger than 4. And then my fifth one, 10. 10 is a number that's bigger than 4. So now they want us to construct a graph, okay? So again, I rewrote my statements down. X is less than -1 or X is greater than 4. So what we did, X is less than -1, so open circle, smaller goes that way. Greater than 4, open circle, goes that way. Now they want us to construct a graph just showing X is less than -1. Open circle, just smaller. Same thing for X is greater than 4. Open circle, getting bigger. Okay, how could we use the graphs from 24B, so my purple one, and 24C to construct 24A? Okay, because they give us this fancy word of or, that means to join the two graphs together, okay? The word or means to take each statement and put them on one graph. So we took our first statement, we took the second statement, and we put them together for the third. Okay, so now we've got another one here. Okay, I've got X is greater than -2 and X is less than 7. Okay, now take note here, guys. They gave us the word and. Okay, remember, or means one or the other. And means it has to be true for both. Both are true. Okay, so the number -4. -4 is smaller than 2, and it's smaller than that. They want greater than, so that doesn't work. The number -2. Well, this says it has to be greater than -2, not equal to, so that won't work. 0, okay? 0 is greater than -2, and it's less than 7, so it's true. Pi, again, that's 3.14. 3.14 is greater than -2, and it's less than 7. The number 7. No, it may be greater than -2, but it is, this says it has to be less than. If it said is less than or equal to, then it could be, but it says it's just less than 7, so no. And then 12. 12 is bigger than 7, so that won't work. Okay, listing 5 more numbers. Guys, so what I figured out is that my X has to fall in between -2 and 7. So I listed some numbers that weren't in here. That'd be -1, +1, 2, 5, and 6. Okay, so let's go ahead and graph this. We had the first statement that said X is greater than -2. We had this second statement that said X is less than 7 and our word and. So what I showed here, okay, my -2, to show that X is greater than -2, I have an open circle and my numbers are going to the right. And X is less than 7, so open circle numbers going to the left. They join together, but they're bound by the -2 and the 7. We cannot fall over here or over here. Okay, and this is just showing how I constructed that. I showed my -2, I showed my +7, and then A is putting them together. Again, the word and means that they must satisfy both rules. Okay, and means that the rules intersect. They only graph where those rules overlap. So here they want us to solve the compound inequality. Guys, compound means more than one. Okay, think of some other classes. One I can think of, a compound fracture. If I have a compound fracture in my arm, guys, that means my arm is broke in more than one spot. It could be in 3 spots, but compound means I broke it at least 2 spots. So what I did here, guys, is I solved this one to get that X is less than 7, and I solved this one to get that X is greater than -2. Okay, we write them with the smaller one first because -2 is smaller than 7. I'm going to write that one first. We said X has to be greater than -2 or X has to be less than 7. Okay. Now, what I did here, guys, was I started with graphing the X is greater than -2. Okay. And that would be this. Let me highlight these for you. My X is greater than -2. That would be this one. Okay. And then I did my X is less than 7. That would be this one. Okay. What that ends up being, guys, is that all the numbers are true. Okay. If I put these together in one statement, that's why I marked it red dot here. Okay. All of them are true. While the green one can't equal the number -2 and the pink one can't equal the number -7, if it equals negative true, that would make this statement true. If this one equaled 7, it would be true. So therefore, it ends up being all real numbers. That was kind of tricky there. Okay, looking at question 28, again, they had us solve these. Remember, and, guys, this is an and statement. Okay, so I solved them and I ended up with X is less than -3 and X has to be greater than or equal to 2. Okay, because it has to satisfy both rules. The word and, it has to satisfy both rules. I'm just going to write this on here so you can see it above the line. Okay, if I graphed this one, that says that X has to be less than -3. And if I graphed this one, that would say X has to be greater than or equal to 2. Again, and means that it has to satisfy both. Well, look at these arrows, guys. There is no number that satisfies both of those rules. There's no number that's smaller than -3 and greater than or equal to 2. So this is what we call an empty set. There's no number that satisfies both rules. Okay. Here, we have this problem. It says the show choir at Musical High School has been raising money to pay for a trip to New York City to see a Broadway musical. They still need at least $180 to pay for their trip. So they've decided to sell candy bars. They will have to pay a $100 setup fee for the candy bars, but they can sell the candy bars for $2 a piece. Unfortunately, the principal has told them that they cannot raise any more than $500 or else they'll have to pay taxes. Okay. Write a compound inequality to describe the situation. So what I did here, I identified the rules. What do they need? They need at least $180. Okay. So rule 1, sell at least $180. How am I going to write that? Greater than or equal to 180. So I have my first problem. Okay. I am $100 down. Okay. There's a $100 setup fee. So I'm already $100 in the hole. That's where I get the minus 100. Okay. Minus 100. But I can sell these at $2 a piece. So $2 a piece minus the 100 that I had to pay up front has to be greater than or equal to 180. Rule number 2 that they give us is that we absolutely cannot sell more than $500. That means that whatever I make has to be less than or equal to $500. So my problem here, same exact part. $2 per candy bar minus the $100 that we're in the hole on has to come out to be less than $500. So we're going to go ahead and solve both of these. Okay, we'll worry about this one first. Rule 1, add 100 to both sides. I get 2x equals $280. And then finally, when we solve that, I get that x has to be greater than or equal to 140. Come over here. Add 100 to both sides. 2x has to be less than or equal to $600. Divide that by 2, and we have to have less than or equal to 300. What this means, again, guys, because this is an and statement, in order to pay for this trade, they need to sell at least 140 bars, but absolutely no more than 300. Okay? Have your teachers help you go back and do some of those reinforced problems.